Once drugs are inside your body, how do they move around and get to where they need to go? There are four main processes. Those are absorption, distribution, metabolism, and excretion. Absorption describes the way the drug moves from its site of administration across one or more membranes, often into the bloodstream. Distribution describes its journey through the bloodstream to reach target cells in specific target molecules within it. Metabolism describes the ways that it eventually gets modified by enzymes and render ineffective. And excretion describes the way it then exits the body, typically either urine or feces. The first step is absorption. If a drug is administered topically, this can mean moving through the skin or a mucous membrane and subsequently through the walls of nearby blood vessels. If administered orally, this would mean being absorbed through the lining of the stomach or intestines, a process which would be slowed by the presence of food. Some drugs will pass through the cells that comprise these membranes by passive transport or active transport, but one way or another they will make through on the way to their destination. Describing this process, it would be appropriate to review the term bioavailability. This term describes the proportion of a drug that is successfully absorbed into systemic circulation. Next is distribution. This is the way the drugs move through the bloodstream after being absorbed into it or injected into it. There are many factors that influence this, like the way it interacts with the components of blood, such as plasma proteins. If the drug binds too tightly to these proteins, it will not be able to reach its target cells. Sometimes a second drug is administered in conjunction with the first that has the higher affinity for their proteins than the first one does. Beyond these blood elements, there are other factors that may hinder the movement of a drug. There are anatomical barriers found in certain organs. The blood-brain barrier prevents certain substances passing out of the bloodstream into brain tissue. Some drugs will not be able to surpass this barrier while others will, such as psychotropic drugs or those affecting the mind. There is also the blood-placental barrier that regulates which substances can pass from the bloodstream of a pregnant woman into the fetus. However, a number of substances that are able to pass through the barrier that can still do harm to the fetus, such as alcohol and certain medication. And then there is a blood-testicular barrier, which prevents many substances from reaching the male testis, therefore making disorder of the testis difficult to treat. After distribution, there is metabolism. This describes any chemical reactions that inactive the drug and target for excretion. If a drug is traveling through the bloodstream, it is highly likely to be metabolized to some degree. For example, if a drug is taken orally, it will be absorbed through the intestinal wall, and for this reason, the part of the circulatory system it enters is a collection of blood vessels called the hepatic portal system. These carry blood directly to the liver and they will be metabolized into normal. This is called the first pass effect. Drugs are metabolized after reaching their target as well. Finally, after metabolization, there is excretion, where the drug or its remnants will finally exit the body. This is typically done by exhalation, sweating, urination, or defecation. The kidneys are heavily involved in this process as they must remove harmful substances from the bloodstream. Some drugs are metabolized into gaseous form and thus easily exhaled. Some drugs are excreted through bile, a substance secreted by the liver to aid in digestion, as bile is circulated back to the liver via enterohepatic circulation, whereby most of the drug can be done by excreted by the kidneys and the rest will exit by the form of feces. Glands that produce fluids such as saliva and sweat can also promote the excretion, though this method tends to be less effective. And with that, we have traced the journey of the drug into the body, around the body,